Okay, this is Unit 6, Lesson 6.3, Similar Polygons. Something we have to remember, if things are similar, there's three things it needs in common. First thing, same shape. So we can't compare a triangle to a square. So it has to be the same shape. They have to have the same angles on the inside. So all the angles are identical no matter what the size is. And the last thing, the side ratios are proportional. So proportional side ratios. Now I'd like someone in their own words to tell me what that third one means. What does proportional side ratios refer to? What am I talking about there? What do you think that means, proportional side ratios?
The ratio of all the sides, like the way they all like go up, the numbers are all proportional.
Good. So they're either going to grow by the same amount or they're going to shrink by the same amount. So this is how we would write our side ratios when we compare them. This is how we write side ratios, right? Okay? And remember, your sides are going to be between two capital letters. So if I want this side right here, I would label that side GH because he's between the G and the H. That's that side, okay? And we use capital letters for the outside angles. That's what we're talking about. Now on the inside, all of these is the letter L. Looks like the letter L, but it's kicked over. That's the angle side, okay? That means angle D equals angle I. So basically what they're telling you is all the inside angles are going to match. So if I said to you, this one right here is 42 degrees, well, if it says that angle G matches angle B, then this guy also has to be 42 degrees. Okay? So that's something that we have to remember. Whenever we increase or decrease an object, the inside angles do stay the same. Okay? Same as this object down here. So for example 1, instead of a triangle, they're going to compare a different object. They've got rectangles. So sometimes they're going to draw a rectangle inside a rectangle, like we've seen triangles drawn inside triangles. Or they could draw one rectangle, looks more like a square. They could draw one rectangle and then draw another rectangle and then label it. Okay, so they could be drawn like this or like this separately. Okay? So when we get them, your first thing you should do is always label them. So the first thing I'm going to do is label on my side. So it says A to B is 10. So I'm going to put a 10 from A to B. Then it says A to D is 6. So A to D is 6, that whole line. A to E is 2. That means this little piece right here is 2. Why do you think they told us that? It helps us find this. How big does that red line have to be? It's got to be 4 because 4 and 2 are going to make the 6. Okay? So they're telling us numbers on purpose. So the next one, determine E to F. So I need to find this one right here. That's going to be my X. So when we set this guy up, and does it tell us? Okay. So we're going to just cross multiply and divide. That's all we're doing. We can put big over small or small over big. It really doesn't matter. So I'm just going to put small on top of big. So my small numbers are 4 and X. And now I got to put the big numbers that match. So vertically, who matches 4? 6 does. And who matches X going left and right? 10 does. Now we've got our ratio set up. Okay, those are our side ratios. Now we're going to cross multiply and divide. So we multiply this way, which they're showing us right here. And then we divide by the 6. And that's what they're showing us right here. They're dividing by the 6. They will divide out the 6 after. Okay? This is showing a reduced form. Because you would get 40 over 6, but that reduces to 20 over 3. That's where they get that number. Okay? So, we're going to get an answer of 6.6 repeating is what we should get. So, x equals 6.6 repeating. So this is the idea between each one of these types of objects. It's just not a triangle now, it's a square. Now, what if I was comparing objects? So here's a different type of object. If they're telling us that they're similar, this little symbol over here means, yes, they are similar. So if they're similar, we know the inside angles match. So that means that if this guy here is 90, this guy here is 90. Okay? So it says we want to find angle E. Well, angle E has to match this guy. So we did. We found him. He's 90 degrees. Okay? Now it wants us to find angle G. Well, they're telling us C is 100. So if C is 100 right there, how big is G? He's 100. He has to be. So he's also 100 degrees. Now we want to find E to F. This is my X. Okay, I'm going to find EF. So I need to compare two sides. We have two numbers. So I've got this guy comparing to this guy. And then I'm going to have X comparing to the 2. Okay? So we're going to put small object over big object. I've got a 2 equals 3. And now I've got to write their matching numbers. So who matches the 2? X does. Who matches 3? 12 does. Do you notice that it's easier to see them once they're actually labeled in colors? If you've got highlighters, try and highlight the ones that match. Okay? And then when you're creating your equations, the actual ratios, it'll be easier. So now we're going to cross multiply this way, and we're going to divide by what's left over. That's going to give us 24 divided by 3 is 8. So we should get E to F is 8. Okay? All right, we want C to D. We want C to D, so we want this leg right there. All right. So, where's C to D? He's there. We've got G to H is 10. So, who's our true ratio in the above one? 3 over 12. So he's the guy we're going to use again. So we're going to use 3 over 12. We're going to put a y over here is equal to y and 10. You have a question, Andrew? No? Okay. All right. So now we're just going to multiply this way and divide by 12. So we're going to cross, multiply, and divide. So to 1 decimal point, it's going to be an exact decimal. Exactly. So this guy here is 2.5. So we're going to say this guy is 2.5. Good job. All right, so now we want the scale factor of the objects. Are we able to look at the bottom number and see what the next bottom number is? Can we do that? Yeah, we can. So what's new divided by old? What's 12 divided by 3? 4. So this guy multiplied by 4 to get larger. So if we're comparing these guys, we're going to get a scale factor of 4. Okay? So AB times by 4 to get bigger. Now, what if this guy is the new object? Or hang on. If this guy is the old and this guy is the new. What if I reverse it? What would that become? 0.5? 0.25, yeah. It would be 1 over 4. All you would do is this. So this guy, make him into a fraction. Every number can be put into a fraction by what on the bottom? A 1. So if I make him into a fraction. Now if I reverse who's new and who's old, all you got to do is flip it. So I would flip this, and you get 1 over 4. Okay, which is 0.25. So we're going to get, this guy here was a 4, this guy here was 0.25, or you can put 1 over 4. Okay? Are we good to go with those? Yeah? All right. Let's take a look at the next one. Yes, they're showing these up here. All right. So we've got this one now. They're putting different numbers. So they have different numbers on everything. So we're going to compare small to big here. So who's the old object? Who's the old object? Bertie? Well, take a look at who says object. The left one. The one that ever says object or O, he's the old object. Okay? Whoever says image is the new object. Okay? So the image is always the new guy. So, did the new guy get smaller or bigger? He got smaller. So we know we're going to be cross-multiplying and dividing, but making things smaller. So, where would I have a true ratio? Which line has a number on both of them, on both objects? See? Good. So BC and FG, they both have numbers. That means that'll be our true ratio when we set it up. So we're going to set up our true ratio. So we need to find our scale factor and then solve for the unknowns. Well, if we want to find our scale factor, we got new over old. So for A, we're going to have S equals new over old. So S equals 20 over 32. So what's that as a decimal? 20 over 32. 0.625. So you should get 0.625. So you should get 20 divided by 32. Okay, small number on top, big number on the bottom. That's how we know they got smaller. Okay, so there's our scale factor. Now we need to use the scale factor in order to, or just set up our side ratios to cross multiply. We got to find x, y, and z. Okay, so I'm just gonna get extra room over here. Oh, I don't think I can move it up that much. Okay, so let's find x first. So I'm going to be using my 20 and 32. So I'm going to have 20 over 32 equals, well, x comes from my big object. And what line does x match? 25. I have to match it to the line that's the same. So if I match x, I have to match x to the same line. So he's going to match 25. So I'm going to put a 25 over here. All right, so now we're going to cross multiply and divide. So cross multiply that guy, and we're going to divide by 20. So how big do we get for x? 40, good. So x equals 40, so this guy's a 40. All right, now we're going to get y and z on the other object. Yeah, you bet. Okay, so we're still going to use our 20 and 32. We have to use the true ratio. So we're going to have 20 over 32. All right, now letter y is this line. So he's going to compare to that line. So I'm going to have a y on top. What number's on the bottom of y? 36. Good job. Okay, so we're cross multiplying this way and dividing by what's left over. So this one's going to give us a decimal. This one's a decimal. So you should get 22.5. So this guy here is 22.5. We find y. Okay? Now we're going to find z. We got to use the same true ratio. So I've got 20 over 32 equals z. Now who matches the z line? 24 matches the z line. If you look at my squiggly blue line, z is squiggly blue, and so is our 24 here. So they match, and now we're going to cross multiply this way and divide by what's left over. Okay? So that guy's an exact answer. We should get 15. Good. Yes, the answers are down here for you to see, but this is how you would set them up if you like to set them up this way better. Okay? So z's 15. So we found every single number that was missing on our diagrams. Okay? Any questions so far? Pretty good? Okay. Let's take a look at a rectangle. Same ideas with rectangles. Now, they tell us areas. Remember, area, they took something and multiplied it by something else. So if I have a square, and they told me that I have a square that's got an area of 100, how do I find the side length of that square? Square root it. So, these numbers have already been squared because they have area. That's what they're showing you here. So we're comparing area 1, small area, to area 2, the big area. So they're putting small over big. So they're saying this guy is our new and this guy's our old is what they're doing. Now how come is because they're showing us this. They're saying our scale factor is 9 to 16, but it's a scale factor of area. So in order to change it to a true scale factor, we have to change it into units that are non-squared, because those are squared units. That's why they have to square root them. So if I square root 9, I'm going to get 3. If I square root 16, I'm going to get 4. And that means my length and width were the same. That means I wasn't dealing with a true rectangle, I was dealing with a square. Okay? So, and then we would set up our scale factor, new over old, which is 3 over 4. And that's where they get this. Okay? So whenever they give you area, you got to square root to find the side first. Okay? This one they're comparing volumes. They compared area here, volume here. Now if I've got a cube, okay, and I want to do volume of cube, that means I'm going to do length times width times height. But if it's a cube, like a sugar cube, we know that all of them are the same size of the sides, right? Every side in a cube is the same size, just like a dice, okay? It's the same size. So because of that, we're going to take and we're going to compare the volumes, okay? Now, how many numbers did area multiply? 2, length and width. How many would volume have to multiply? 3 numbers. So here we square rooted. Here this is called a cube root. Okay? So look at your calculator and see if you have a cube root button. Look and see if you have a cube root button. Some of them do, some of them don't. Okay? Try and find if you've got that cube root button. Okay? Is that the 3 inside right there? Okay, that's your cube root. So the cube root button's got a 3 in the check mark part. It's got a little 3 in the check mark part. So if you go cube root 8, you'll get a 2. And that means, this guy, cube root 27, you get 3. So that means that this one object, this guy was a 2 by 2 by 2, and the other guy was a 3 by 3 by 3. That's what they're telling us. Okay? The first one, to get a volume of 8, was a 2 by 2 by 2. Okay? Alright, so that's how we do that. How would we draw them if we had to draw them? Well, we don't construct them. All we're doing is comparing them. So for here, these are all we compare. Now, if we're going to draw new ones, because sometimes they'll say, here's your scale factor, draw me a new object. And that's okay, we can. But when we do, we have to make sure that our angles are the same, our side ratios are proportional, and we need that scale factor. We need that, okay, in order to draw new ones. So this guy here, this one is example 6. They're comparing on example 6. So it says, draw a polygon, A prime, B prime, C prime, D prime, E prime, that is similar to this guy, and it says the scale factor is 2. So what would it mean that all those numbers did? If the scale factor is 2, what would happen to all those numbers? They all multiply by 2. So here, okay, they're saying this is the new object. That's the difference. They're saying the old object was this guy. So the old object, we don't know how big everything was, but the new object has these ones. And it says the old object grew by times 2. That's what this means. The old object grew to be times 2. So then what was the original object? How would I find that? What's the opposite? We divide by 2 to find it. So I would take all of my sides. There's all my sides that match this guy. And I would divide them by 2. And that gives me all of these sides. That's what they actually did. Okay? Because they're comparing, saying that the new object is 2 times bigger. Well, then the small object had to be quite a bit smaller. And this is the size of the small object. Okay? What they're showing here is they're showing the new divided by old. New divided by old. And if you do new divided by old for every side, we're going to get the same scale factor for everything. And we have to, because it is new divided by old. Okay? Any questions with that? We're going to do another practice. So let's open up to page 5. Page 5, we're going to do this question right up here. Okay? So we got this one. So, the same thing we've been doing. So we're going to take one small object and put it on top of the new object. So we've got old and we've got new. Now, do we have to put new over old? Nope, we can do whatever we want. We can go small over big, big over small. Because all we're doing is cross multiplying. Okay? If we know 3 numbers out of 4, we're just cross multiplying. So, the small object is going to go on top. So we're going to have a 3 and a 9. So who matches the 3 on the bigger object? 6 does. So that means X matches 9. Okay? Now we're going to cross multiply this way and divide by what's left over. Okay? So we need to cross multiply and divide. We are going to get 18, exactly. So, exactly. So this guy gives us 18. So my scale factor, what happened to this guy? What did 9 times by to get 18? 2. So our scale factor is a 2. Okay? So, this one shows you to line up your matching sides. It tells you your steps. Then it says solve for your unknown by cross multiply and divide. Okay? So make sure you throw your X in there, show your cross multiply and divide. Okay? Any questions so far on 6.3? Okay, this concludes lesson 6.3.